Welcome to monochemistry. In this lesson, we're going to learn how to properly balance redox reactions. This is question 4F from the sheet titled Redox Questions that's on the Moodle site, so you can follow along. Here are the steps to balancing redox reactions. AP Chemistry students may have already been exposed to these, but if you're in Chemistry 12, this will probably be the first time that you're seeing them. So I want you to copy down the steps if you're in Chem 12. You follow along if you're in AP Chem. Note, before you start balancing a redox reaction, as I've specified here, you must first write a net ionic equation for the reaction. Once you've done that, you're going to write the oxidation numbers and identify what's oxidized and reduced. 2, write half reactions. 3, balance the half reactions in an acidic medium for these questions. And multiply the half reactions by whole numbers so the electrons will end up canceling out. And then finally, add the half reactions together Hess's law style. So as you can see, I've written this equation here in its net ionic form. It's important to note what I've done here, because it may be a little bit different than what you've remember from the solutions unit. First of all, acids that are strong, and only acids that are strong, can dissociate in water. So even though in this particular instance we have 1, 2, 3 acids, we can only dissociate those that are strong. Hydrochloric and nitric acid are strong. This is aqueous, yes, but it's a weak acid and therefore cannot dissociate, and that's why I've left it here. This is also a gas. Remember, solids, liquids, and gases do not break apart in net ionic equations. And so this guy here, which is a gas, also a molecular compound, is not going to break apart. So I've written my net ionic equation, and now I'm ready to move on. I've also written here the oxidation numbers, and I can see that the chloride, the Cl minus, goes from being a 1 minus to a 1 plus. And the nitrogen goes from being a plus 5 to a plus 2. Therefore, the Cl is oxidized, and the nitrogen is reduced. If you're not quite sure how to do that, it's important that you go back and review the videos on writing oxidation numbers and identifying redox reactions. Alright, so we're going to start by writing the half reactions, we're going to balance them, and then we're going to multiply them by whole numbers so that the electrons will cancel out. So to start with, I have to write my half reaction. So my oxidation is going to involve the Cl, and my reduction is going to involve the nitrogen. Now the Cl minus is all by itself in my net ionic equation, so I can start with the Cl minus. Unfortunately, on the product side, my Cl is attached to a weak acid, which cannot dissociate. And so therefore, I can't just arbitrarily take it out of the HClO. I have to leave it as it is, just like I did in my net ionic equation. Same thing for the nitrate. The N is attached to the O3. That makes NO3 minus. And the N is also attached to the O on the product side, which makes NO. So I have to balance these. How I'm going to do that is as follows. First of all, I'm going to start by balancing any oxygens by adding water to this process. Now, I know that seems kind of strange, but I think you'll agree if you look at the original equation, which is up here, there must be water present because I have aqueous solutions. Where would the water be? Well, it's dissolved, these things. So it's there, which means I can add it. And in this case, I need to add some water to this side to balance out the O's. So I'm going to add a plus, get my color right here, I'm going to add plus 1 H2O, because there's only one oxygen on the other side. Now, when I do that, I've now created another problem, which is that I don't have enough hydrogens. I have 1 hydrogen on this side, and I have 2 on this side. So what I'm going to do is I'm going to ensure that there's enough hydrogens on the other side. And how I'm going to do that is I'm going to add some H plus to this side. Now I can do that because there is an acid on this side. It's a weak acid, mind, but still, I can do that. Now what I notice is that both sides are balanced in terms of atoms, but not balanced in terms of charge. I have 1 Cl, 1 Cl, 2 hydrogens, 2 hydrogens, 1 oxygen, so that's good. This side has an overall -1 charge. -1, and this whole thing has a 0 charge. So -1 and 0 give me -1. This side has a 0, +1, +1 charge. I have to make those balance, and the only way I can do that is by adding electrons. So what I'm going to do is I'm going to go ahead and I'm going to add 2 electrons to this side. Remember, I have to add electrons to make the charges on both sides, here and here, balance out. This side had a -1, this side had a +1. 2 electrons would give this side a -1 charge overall. Now I'm going to do the exact same thing with my nitrogen, my reduction half reaction. So this side, the reactant side, has 3 oxygens and the product side has 1. So in order to fix that, I need to add water. Remember, use water to balance out your oxygens. So I'm going to use plus 2H2O to balance out the oxygens, because there's already 1 there. I need 3. But now I've created the problem of having hydrogens. Well, I'm going to go ahead and add 4H plus to this side. Why? Because I have 4 hydrogens here and none over here. I need to balance that out. Can I add H pluses to this side? Of course I can, because I've got these 2 acids that were in the original equation. Okay. Now what I need to do, as you already know, is to balance out the charge. This side has a total charge of 0. 0, 0. 0 plus 0 equals 0. This charge has a total charge of positive 3. How do I make positive 3 become 0? By adding 3 electrons. Okay? Now, before I can add these 2 equations together, Hess's law style, I got to go ahead and make sure that my electrons are going to cancel out. That's the only criteria for adding these equations together. I can't add an equation that has 3 electrons on one side here and 2 on this side. I have to make sure they are going to cancel out. So in this particular instance, the easiest way to do that is to multiply this equation by 3 and to multiply this equation by 2. Now that I'm going to rewrite those equations. And remember, I multiply everything in those equations by the whole number. So 3 gets multiplied through this whole equation, and 2 gets multiplied through this whole equation. I'm going to rewrite them, and then I'm going to add them together Hess's law style. Alright, so we've done what I said to do, which was to multiply each of the half reactions in such a way that the electrons will cancel out. So now we've got this and this canceling out. So what we're going to do is we are going to add these 2 equations together, Hess's law style. Okay, so the first thing I'm going to look for is the things that are the same in both equations, and either add them together or subtract them, depending on which side of the reaction they're on. So in this case, notice that I have 3H2O here and 4H2O here. Well, there's more on this side, so this guy's going to be gone, and that's going to leave me with just H2O. Okay, I have 3 hydrogens, H pluses here, 8 hydrogens there. That's going to cancel, and that's going to be left with 5. So 5H plus. Nothing else really cancels out, so I'm just going to go ahead and put everything in here that I have. So I'm going to have 3Cl minus plus 2NO3 minus plus 5H plus yields 3HClO plus 2NO plus H2O. And there we have it. There's our balanced redox reaction. And to check, all I have to do is make sure that I have the same number of each element on both sides of the equation. And then as you can see, I do. I have 3 chlorines, I have 2 nitrogens, I have 6 oxygens, and I have 5 hydrogens on each side of this equation. Now you might be asking, why would I go through all this trouble when I could just simply balance it the same way we've been balancing for the last 2 years? And the answer is, for a lot of these redox reactions, if you try and balance them the way we've always balanced them, it's not going to work. It's going to take you a really long time to get the right answer. And while I know this seems like it's going to take a long time, the more practice you get, it'll actually be a lot faster than you think. And so what I want you to do is I want you to try a couple more of these. Let's try E and G. Let's try questions E and G off the same sheet. I want you to follow the steps and see what you can come up with for answers. And that, in a nutshell, is how you balance redox reactions. Bring your questions to class.